We're here at some of the demos at the Brooklyn 6G Summit from Nokia Bell Labs. And our research in 6G is a combination of the fundamentals of 6G and primarily also AI. But then also how will we use this 6G in future applications in verticals. And actually in no logical order, I'm actually standing here right in front of our project, the Cognitive Digital Mine, where we're actually collaborating with a mining company in Brazil and getting what I would call a perfect digital twin of the mine. For one, to get a digital twin of the network, because the geometry of a mine is constantly changing. With people are dynamiting the mine. And that means that the RF propagation change. And so with a perfect digital twin of the mine, we can also have a better digital twin of the network and the network quality. Or we can do a lot more with that. We have actually created, and maybe I should invite in Lelio, because he has been the principal research engineer on this. And we actually just graduated this research into an internal incubation.
Hello, so this is our demo of the CDM, the Cognitive Digital Mine, which is a new venture in Nokia stemming out of the Bell Labs innovation. And the idea really came out of after visiting a mine and understanding what are the key challenges for network connectivity and operations when it's used for autonomous operation for increasing safety and productivity into hostile environments like a mine. And the idea here that we have a solution that allows us to create seamlessly a digital twin of the network and operation altogether. And the key idea here is that when you have things like this autonomous truck connected to the network influences the operation, but also the operation influences the network. So here what we see is a way of optimizing continuously the experience that this truck have attached on our networks so that we can make sure that they can predict as expected. Now here what we do into this project, we try to automate the creation of digital twins so that we can, for instance, import all the maps of the mine continuously inside our operation to understand how the network will look like, but also how the network might evolve to predict important KPIs inside an operation and how the propagation will affect the operation itself. In this case here, we are computing the probability that this use case can be deployed with high confidence that will deliver the results as expected. And our results in our 1-year POC demo shows that we can reduce up to 9% unplanned stops in the mine. We can increase 80% of the safety of the workers because we don't have to send workers to troubleshoot and diagnose conditions of stoppage of the operation. And with all the data that this digital twin collects, we can automate and we can optimize 25% of the planning operation, which is the bottleneck of the mine. In the future, where this is going in a direction where if we can predict, for instance, the mine, the demands, the network demands, and so on, that basically means that we can migrate from a model in which we just provide connectivity from the edges of the mine to something that we experience over the World Cup, we experience every Sunday in games, which is related, more similar to a spider carrier. This is where we can put high-frequency 5G and the future 6G network attached to this, what we call zipline hauling, and then commanded and controlled by the intelligence that we have on the box that will be deployed on the tracks. We can predict where the demand will be and always have a network that maximizes the SLA of the operation, which is our goal.